Hello friends, this is Assistant Professor Trupti Kulkarni. Today we'll talk about 8085 addressing modes and instruction set. As we have seen already in the last video that what is instruction and what are the length of instruction. So basically instruction is nothing but opcode and the operand, where opcode is nothing but because of that the operation took place, and the operand is nothing but on which the operation took place. The next we have seen that is the length of instruction. So there is a 1 byte instruction, 2 byte instruction and 3 byte instruction, and these are the examples for the same. Now today we'll talk about what are the addressing mode present in 8085 assembly language programming. So there are the 5 addressing mode. First is register addressing mode, second is direct addressing mode, third is indirect addressing mode, fourth is immediate addressing mode, and the fifth one is implied or implicit addressing mode. Now first of all, what do you mean by addressing mode? So addressing mode is nothing but how the operands are specified in the instructions are nothing but the addressing mode. So how the address is specified in the instruction is nothing but addressing mode. So first we'll see what do you mean by register addressing mode. So here in this addressing mode, basically the operands are pure register. As we have seen, the instruction is made up of opcode and operand. So opcode is nothing but because of that the operation took place, and operands are nothing but on which the operation took place. So here the move is a opcode and A and B are the operand. So addressing mode means what type of operands we are using, accordingly that the addressing mode decides. So here you can see the A and B are the registers. So here the operands are pure registers. So that is nothing but the register addressing mode. The next is direct addressing mode. So direct addressing mode is nothing but when the address, or you can say a memory location, is specified directly in the instruction, then it is called as direct addressing mode. Or simply you can say when the address is directly specified in the instruction, then it is called as direct addressing mode. For the example, we are taking LDA D00H, that is a load accumulator with this address. So here this is an address. So when the address is specified in the instruction, then that is a direct addressing mode. The third one is indirect addressing mode. So as we have seen the direct addressing mode, so address is specified directly into the instruction. Indirect addressing mode means here the address is specified indirectly in the instruction. So now what do you mean by indirectly? Indirectly means here it is written move A comma M. Move A comma M means M is nothing but the memory. Memory is actually a HL pair who is having one memory location, and whatever the content of that memory location is going to be copied into the accumulator. So here the address is specified in the instruction, is specified in HL pair, or you can say a memory. It is not directly specified in the instruction. So this is called as indirect addressing mode. The fourth one is immediate addressing mode. Here the data is immediately coming in the instruction, so that is called as immediate addressing mode. So when the data is specified in the instruction, then it is called as immediate addressing mode. Or you can say simply when the instruction is ending with an I, that time it is an immediate addressing mode. MVI, LXI, these are some example of this. So if I write MVI B, 05H, that means 05 is a data which will be copied into register B. So move immediate data which is present in the instruction 05H should copy into the B. And the last one is implied addressing mode or implicit addressing mode. Now this is a quite simplest addressing mode where the operands are absent. So operands are not present in the instruction, then it is called as implied or implicit addressing mode. For example, we can say exchange, that is a XCHG exchange. So here there is no operand is present. The instruction itself says that the content of HL pair and DE pair is supposed to get exchanged. You can give the example like a rotate instruction, that is a RAR, RAL. These all are the instruction which is not having any operand. Or you can say DA, that is a decimal adjust accumulator. There is no again operand is present. So these all are the addressing mode. So we have seen the 5 addressing mode, that is a register addressing mode, direct addressing mode, indirect addressing mode, immediate addressing mode, and the last one is implied or implicit addressing mode. So register is nothing but when the operands are pure register. Direct means when the directly address is specified in the instruction. Indirect means indirectly address is specified. That means the address is in HL pair and we are denoting it by M, that is a memory. And fourth one is immediate addressing mode. Immediately data is coming into the instruction, so that is the immediate addressing mode. And the last one is implied or implicit addressing mode, where the operands are absent, or you can say the operands are not present in the instruction. So after seeing the instruction or after seeing the addressing mode, we will go to the next topic, that is the instruction set of 8085. Now basically in assembly language programming, there are the different types of instructions are present. We have seen the different addressing mode. Now what are the different types of instructions, or you can say the group of instructions in the microprocessor is called as instruction set. Now 8085 has 246 instructions. Each instruction is represented by 8-bit binary value. Now these 8-bit binary value is called as opcode of that particular instruction, or you can say the instruction byte. Now what is the classification of instruction set? So as we have seen, there are the different addressing mode. Same way, there are some different types of instructions are present over there. So the some instructions are basically used to transfer data, that belongs to data transfer instruction. Some instructions are basically used to perform the arithmetic operation like add, subtract. So that is nothing but the arithmetic instruction. The third one is a logical instruction which perform logical AND or XOR operations. The fourth one is a branching instruction. Branching instruction is basically used to give the loop into your program, that is a jump instruction. So you can say JMP, JNZ and JNC. These are some of the examples for branching instruction. And the last one is a control instruction, that is a halt, DI and EI, that is a decibel interrupt, enable interrupt. So these are some of the, you can say, the examples of these instructions. So we'll start with first data transfer instruction. Now data transfer instructions are basically used to move data from one location to another location, or you can say from source to a destination. So data can be moved between the registers, between the memory locations, or between memory location to a register. So here data is going to be copied, so that means the data will be present in the source as well as in the destination. So here the copy paste operation is going to be performed. So that means the content of source is not going to be get changed. So the data will present in source as well as in the destination. So now we'll see the first instruction of data transfer, that is a move instruction. So now the move instruction may have the different operands, like it may have registers, it may have register with the memory and memory with again a register. So here you can see the source and destination are getting changed. So very first time the destination and source are registered. So when the operands are pure register, this is a register addressing mode. Now here for the second, it is the destination is a register and the source is memory. So, memory is nothing but the HL pair which is having a memory location, and the content of that memory location is going to be copy into this register. And for the third one, that is a memory is a destination and the source is a register. So, the content of this register is going to be copy into the memory location which is specified in the HL pair. So, now here the move instruction basically perform the copy paste operation. So, the content of source register or the content of source is going to be copied into the destination. So, we can see an example, move B comma C. So, here the content of C is going to be copied into the B. So, for example, if I say C is having 20H and B is having 10H. So, after the instruction get execute, the content of C will be there in the B. So, the C as well as B will have the 20H. We will see the next data transfer instruction, that is the MVI. So, MVI is basically move immediate data. So, here the operand can be ID comma data or M comma data. So, here register the data can be copied into the register or can be copied into a memory. So, for example, if I write MVI A comma 57H, that means I am loading this data into an accumulator. If I write MVI M comma 57H, that means I am loading this data into memory location which is specified by the HL register pair. So, it is a move immediate 8-bit data. That means if instruction carry two numbers, it is a 2-byte instruction. Previously, the instruction which we have seen, that is a move instruction, it does not have any number, that means it is a 1-byte instruction. If the operands are pure registers, this is a register addressing mode. If operand is a data, that means it is an immediate addressing mode. If instruction carry two numbers, it is a 2-byte instruction. Now, we will go to the next instruction, that is LXI. So, LXI is nothing but a load register pair immediate. That means whatever the data is specified in the instruction is going to be copied into the register pair. For example, if I write LXI H comma 1, 2, 3, 4 H. So, here 1, 2, 3, 4 H is my data, and here the destination is HL pair, but here we will mention only H, that means nothing but the HL pair. So, 34 will load into L and 12 will load into H. So, if you want to load 16-bit data, you need to use register pair. So, you can use HL, you can use D, or you can use BC. So, these are the register pair which are there with the microprocessor 8085. So, if you want to load 8-bit data, you can use MVI. If you want to load 16-bit data, you can use LXI. So, here LXI always come with register pair. So, if I write H, that means I am writing HL. If I write LXI B, that means nothing but the BC register pair. So, again you can see this instruction carry 4 numbers. If the instruction carry 4 numbers, it is a 3-byte instruction. The next instruction is LDA, load accumulator direct. Now, here operand is the address. So, as we have seen, if the address is directly specified in the instruction, then it is a direct addressing mode. So, LDA 16-bit address. So, whatever the mentioned address is there, the content of this address is going to be copied into accumulator. Means if you want to take a data from a memory location, you are supposed to use LDA, load accumulator direct. For example, if I write LDA C000H, that means the content of C000H will copy into accumulator. For example, after execution of this instruction, the A will have 05H, which is there in C000H, that is the 05H. The next instruction is LDAX. Operand is register pair. Again, you can use either a BC register pair or you can use D register pair. The load accumulator direct. Here, the content of design contained of specified register pair point to the memory location. That means the instruction copies the content of memory location to accumulator. So, here the memory location will be specified in this register pair and the content of that memory location will copy into accumulator. For example, if I write LDAX-B, that means BC register pair will have one memory location and whatever the content of that memory location is going to be copied into accumulator. And next is LHLD. LHLD is nothing but, again this instruction comes with the 16-bit address. So, LHLD means this instruction copies the content of memory location point out by 16-bit address into register L. For example, if I write LHLD 2040H, that means the content of 2040H will copy into L and the next memory location, that is a 2041H, the content of 2041H will copy into H. So, the memory location which is specified in the instruction, the content of that memory location will copy into L and the next memory location content will copy into H. Again, this is a direct addressing mode because the address is specified directly. As you can see that the 4 numbers are present. Again, this is a 3-byte instruction. Now, we have seen the load instructions till now. Now, we will see the store instruction. As we have seen the load instruction, the destination comes first and the source comes afterwards. Now, in store instruction, it will be reverse of it. That means, if I write STA 16-bit address, that means the accumulator content will copy into this 16-bit address, store accumulator direct. So, if after performing any operation or any program, if you want to store a result, okay, which is there in the accumulator, and if you want to store this result at a particular memory location, you are supposed to use STA. So, that means the content of accumulator, mostly the arithmetic operation, the result store in accumulator. So, if you need to store this data or that result at a particular memory location, so I will write STA 2500H, that means accumulator content will store at 2500H. So, you can see after execution the content of accumulator will be there in the same memory location. So, I have mentioned the wrong memory location. So, here it should be 2500H only. We will see the next, that is the STAX. As we have seen the LDAX, it is exactly opposite STAX. So, here the content of accumulator are copied into the memory location which is specified by the register pair. That means, if I write STAX-B, that means accumulator content will goes into the memory location which is specified by the BC register pair. So, BC register pair will have one memory location. For example, I will write BC register pair will have one memory location and in that memory location there will be data, and this data is going to be replaced with accumulator content. So, here the content of accumulator will goes to this memory location. The next is SHLD. As we have seen the LHLD, again this is the opposite of LHLD. So, here the store HL pair. So, now here the content of L will goes into the specified memory location and the content of H will goes into the next memory location. So, here you can see SHLD 2500H. So, after execution the content of L will goes into 2500H and the content of H will goes into 2551H. And here we comes at the last instruction of data transfer, that is exchange. So, now exchange is a one instruction. You can see there is no operand is present. So that is nothing but the implied or implicit addressing mode. So you can see the exchange instruction is basically used to exchange the content of HL and DE pair. So as you can see in the description, the content of H will goes into L and the content of L will goes into H. Similarly, the content of D will go into E and the content of E will goes into D. So exchange is the implied addressing mode and there is no number is present, so it is a 1 byte instruction. So today we have seen all the data transfer instruction. So for the next video, we will see the arithmetic instruction. Hope you like this video. So please do like, share and subscribe. Thank you.